Hello and welcome to my LeetCode problem tutorial video. Today we're going to talk about a problem called container with most water. We're going to look at the problem description and an example, and then I'm going to talk about two solutions, where I explain the solution, give an example, and analyze the time complexity. So first, let's look at the problem. You're given an integer array of non-negative numbers where each number represents the height at that position. For example, if you're given this array, the heights are 1, 8, 6, 2, and so on. And you have to return the maximum water that can be trapped between two heights. In this example, you have to return 49 because at indices 1 and last one contain 49 units of water. So you return 49. The first solution I'm going to talk about is brute force. This solution takes every single pair of heights, calculates the water between those two heights, and updates the maximum if needed. The formula for calculating water between two heights is the absolute value of the difference of the two indices multiplied by the minimum of both the heights. In this example, we're given this height array, so we start from the first two heights and calculate the amount of water trapped in between them. The height is 5, and the maximum is currently negative infinity, so we update the maximum to 5. Then we go on to the next pair, and then we update the maximum to 12, because the water trapped in between those two places is 12. We keep doing this. We update the maximum to 21 now, but now the height is 8, so we don't update the maximum because 8 is less than 21, which is the previous max. We continue doing this until we reach the end. This method is really inefficient because we found the correct solution really early on, but we still go on because we hope that we find a better solution later. And finally, we're done. Let's look at how to program it. We first create the max variable, which will be our final answer. Then we create both for loops to iterate through the loop with 2 pointers. Then we calculate the amount of water trapped between those and update the maximum if needed. And finally, we return our answer. The first iteration has n-1 checks, the second iteration has n-2 checks, all the way till the last iteration, which has 1 check. This is equal to n-1 plus n-2 all the way till plus 1, which is O of n squared. As you can see, we found the first optimal solution really early on, but we hoped that there would be a better solution, but there wasn't. There's a more optimized solution to this problem, which finds the optimal solution and then returns it without doing any redundant checks. The second solution I'm going to talk about is 2 pointers. Since we know that the farther away the heights are, the more water that can be trapped in between them, we first create the 2 pointers on the very extreme left and the extreme right. And then we calculate the water trapped between those. And then we know that if we update the height with the larger amount of larger height, it won't make any sense because even if you find a larger height after that, it'll still be limited by the smaller height. So every iteration, we update the smaller height. We do this until the 2 pointers meet, which is when we return the maximum height we found. For example, if we're given this height array, we start at the 2 extreme sides, and the maximum water, which is just the current water, is 15 units. We see that on the right side, if we update it, we get a much larger height, but that won't make any sense because on the left there's a smaller height anyways, so it won't matter. So we update the smaller height. Right now, the maximum amount of water is larger with 16 units of water. So, and now the right side has a smaller height, so we update that. Now we see both heights are equal, so you can choose any height to update. In this case, we choose the left side. For no reason, you could also choose the right side too. And now the left side is smaller, so we update it again. And still, the water trapped in between is not larger than the maximum. To program it, we first create a max variable, which is our final answer. And then we create both the pointers and repeat this until the left pointer is smaller than the right pointer. Then we update the maximum if the current water trapped is larger than the last maximum. And then we update the pointer with less water, with the smaller height, and then return the maximum at the end. The time complexity is just O of n, since it's done with one pass. And this algorithm is the best for this problem because it uses more intuition and limits all the redundant checks. This is the last solution I'm going to talk about today. I hope you enjoyed this video, and if you did, like and subscribe.